Okay, 24.3, the exercises. We'll go through them one by one. Let's do the first one first, and then we'll move forward. So let's take a look. What do we have here? We have two polynomials. We need to factor those polynomials. First polynomial appears to be quite easy to factor, and I'll write that down for you. And by simple trial factors, what do you get? Looks like 2x and 2x. And the 3, there's no choice in that. It's got to be 3 and 1. And what do you get over there? Let's take a look. It looks like plus, minus. I'll check it, though. That would give you 2x times 2x, 4x squared. Works beautifully. The last term works beautifully. Do we get the internal term? Well, minus 2x plus 6x is, of course, 4x. So this works nice. And I want to point out that factorization is clearly written down right over here. Get my eraser out. I'm done with that one. And as I said from the last section, sometimes it's helpful to know a factorization of one to help you with the other. And so looking at the other is certainly a cubic problem. Yeah, I'm not going to say grouping patterns, but it appears that, maybe one of those factors is in there. And then someone says, what factor would you choose? Well, it's a tough one. Let's take a look at it. And I would do a long division. And the long division I would do, I'm looking at the 6x cubed. By the way, if you see the factorization, there is no reason to do a long division. Well, let's think about it. And, thinking about that, well, I don't think I would use 2x minus 1. I think I'd use the 2x plus 3. Let me tell you why that is. Well, let's go through it. Let's see what we get over here. So you get 3x squared. 3x squared times 2x is going to be 6x cubed. And then you're going to get 9x squared. Subtract, what do you get? 2x squared minus x minus 6. Repeat, what do you get now? Plus x. What does that give you? 2x squared plus 3x. Subtract, what do you get? Minus 4x minus 6. Repeat, that would be a minus 2. What do you have there? Minus 4x minus 6, which is 0. So I have it partially factored. Let's write that down. And once I get a linear factor and a quadratic factor, things do become easier. And the reason that the quadratic factor, generally speaking, are easy to factor. So what do you get over here? 2x plus 3. And then I look at the, 3x squared. It's got to be 3x and x if it's going to work. And then what do I get over there? If it doesn't work, though, that's fine. I still have a factor in common. Looking at that, it would be, let's see, 2 and 1, right? So I'm going to say 2 and 1. And then I got to get some signs here. So 3x squared definitely works beautifully. I need a minus 2 in the end, so I need a plus minus somewhere. So let's see, 3. Yeah, I think I got it over here. All right, so I got it factored. I want to point out this is the factorization that we've obtained. Let's look at the k to make sure they've got that one too. Well, 3x minus 2, I see that. 2x plus 3, I see that. And x plus 1. Now the question becomes is, what do they have in common? What's the greatest thing they have in common? Well, what they have in common is only the 2x plus 3. It's in both of them. So the GCF is 2x plus 3. All right? Thank you.